Okay, let's move on to section 4.5, which is about precipitation reactions. A precipitation reaction is a double displacement reaction in which a solid forms and separates from the solution. When ionic compounds dissolve in water, the resulting solution contains the separated ions, and the precipitate is the solid that forms. So an example, the reaction of potassium chromate and barium nitrate going to barium chromate. If we were to put potassium chromate and barium nitrate together in water, they would ionize. So the barium ions would separate and the chromate ions would separate, and they would join together to produce barium chromate. Now there are some other ions that are around, and that is the potassium ion and the nitrate ion. The potassium and nitrate ions are called spectator ions because they remain unchanged in the solution. So you have in A, you have all of that stuff that you've added into your initial reaction. In B, now the barium and chromate have formed barium chromate, but you still have the potassium and the nitrate ions floating around as spectator ions. If we were to look at an example of that in not drawing form, you would see the precipitate down at the bottom in figure C, and the spectator ions you can't see because they are so small, but they are in the liquid. Some quick definitions for you. Soluble means that it will dissolve, a solid will dissolve in a solution. When you have this type of reaction, you typically use the term AQ in the reaction equation. Insoluble means the solid does not dissolve. So when you have a reaction, you would use S to indicate that it is still solid. Just as a note, insoluble and slightly soluble, generally you should assume that they mean the same thing. Now, let's go over the rules for solubility. These are some that you're going to want to write down. First, most nitrate salts, that's salts made with the nitrate ion, are soluble, meaning they will dissolve in water. Most alkali metal, that's group 1A salts, and also ammonium, are soluble. Most calcium, bromine, and iodine salts are soluble, except, and these are some important ones to remember, silver, lead, and mercury. Most sulfate salts are soluble except for barium sulfate, lead sulfate, mercury sulfate, and calcium sulfate. Most hydroxides are only slightly soluble. The exceptions here, sodium hydroxide and potassium hydroxide are soluble. Barium hydroxide and calcium hydroxide are marginally soluble. Finally, most sulfur, the ones listed here, phosphate salts, are only slightly soluble, except for those containing cations from number 2. So that's the alkali metals. This is a list that you're going to have to memorize. There's just no way around it. Let's look at a sample problem. Which of the following ions form compounds with lead that are generally soluble in water? Pause it here, think about it for a sec, look back at your list. If you said C, you would be correct. A, B, and D are all going to form precipitates, and a compound cannot form between lead and sodium for E there. We're going to move on now to section 4.6, describing reactions in solution. So the formula equation is probably what you're used to using. It's also considered the molecular equation, and it gives the overall reaction stoichiometry. but it misses a few things. It doesn't really give you the true form of the reactants and the products in solution. In general, we only show reactants and products as compounds, but that's not always the case. So when we're doing when I'm asking you to describe a reaction in a solution, you're going to need to use solubility rules to determine which compounds are aqueous and which compounds are solid. So an example here, if you had silver nitrate and you mixed it with sodium chloride, you're going to produce silver chloride, which is a solid, and sodium nitrate. So let's take a look.